Well, friends, we have our new related rate video, and we're talking about related rates and similar triangles in video E of our 4.6 series. A person is 6 feet tall and is walking toward a street light at 2 feet per second. The light is 20 feet tall. How is the length of their shadow changing when they are 10 feet from the light? So, what are we looking for? What are we given? So we're certainly given this 2 feet per second, and I'm going to call that dp dt. And p will be the person's distance from the light, and I'm going to make this just 2 feet per second. And I'm not sure if that's going to be positive or negative. They're walking toward the light, but I'm going to wait until my diagram before I fill in that spot, but I'm thinking about it. Now, what are we asked to find? We're asked to find how the shadow is changing. I'm going to call that ds dt. And we need to know that when that distance, when p is equal to 10 feet. Now, let's make our picture. And what I can draw here is some street light. And I'll draw a person. And so this distance right here will be P. And the street light is going to make a shadow off the top of that person's head. And the shadow will be here. Yeah. So that'll be P. This will be S. All right. We also know that this height here is 20. And that the person's height is 6. So what we're going to make is we have to make some relationship now. And the relationship is a similar triangle relationship. I have a small triangle is to the big triangle. And so if I wanted to, I could just start saying 6 is to 20. Yes, the vertical is to the vertical. As this side, S is to the big side, P plus S. Now, I don't think I want to leave it quite like this. I think we can do a little bit of housework here because I certainly don't want to have to do the quotient rule. So I think I'm going to multiply up and just do that. So I'll rewrite this as 6P plus 6S is equal to 20S. And I hope that that sits okay with you. In fact, I'm going to go one step further. I'm just going to bring that S over. We'll have 6P is equal to 14S. Now, in step 4, we're going to take our derivative of this, keeping in mind that this distance of the person is changing and the shadow distance is also changing, yes? So let's take the derivative. So P is a function of time, S is a function of time. So we're going to have 6 dP dt, and that will equal 14 ds dt. What were we asked to solve for? Ds dt, and we're going to do that in step 5. And so we've gotten ds dt is equal to 6 over 14 dP dt. What does that tell me? If I look to plug in my information now, oh, and you know what I didn't do? I didn't make this negative, did I? I didn't make that negative. And it is negative because the person is getting closer. So now I can put this in and we can see that ds dt is equal to 6 over 14 times negative 2. And it looks like we're done. ds dt is equal to negative 12 over 14, or negative 6/7. And the units here are feet per second. Let's think about a little gut check here. Does that make sense? why this is changing at a slower rate than this is. And I think that's fine, just because here we have the angle to the person's head and then to the ground. And yeah, I mean, it is certainly going to be getting smaller, but I think as we get closer, that should get faster and faster and faster. So yeah. All right, friends, we're done. We're going to do one more related rates with similar triangles, this time involving a cone.